All right, so today we're going to be talking about the graphs of a unit circle. So when we think about the inverse, we think about the fact that we're going to flip our x and y values as we've done previously with other functions. So when we graph a regular trig function, we are actually graphing the angle measurement, okay, so the angle and then the side length. So we're talking about the side length of sine versus the side length of cosine. So when we actually do the inverse, that's going to flip around, and then we're going to be talking about the side length of sine and cosine compared to giving us the angle measurement with the y value, okay? Now, in order to do this properly, we're going to have to restrict the domain. So when we think about a sine graph, so a sine graph is going to keep repeating its wave over and over because the lengths of those values keep repeating as you rotate around your unit circle. So as I look at my values here, and sine is, I have 1/2, I have negative square root of 2, then I have the square root of 3 over 2 and 1. Now, my sine values are going to start repeating as I hit quadrant 2, and they're going to be different over here, but we have to make sure that those values are connected because we're thinking about graphing it in terms of the origin. So when we look at it, we're only going to focus sine on quadrants 1 and 4. Now, when we focus on quadrants 1 and 4, we're looking at the fact that this is 30 degrees, 45, and 60, and we're going to call this negative 30 degrees, negative 45 degrees, and negative 60 degrees in order for them to be connected like they would when we graph the actual sine and cosine on a coordinate plane. So with that being said, you would need to talk about these values. Now, I didn't include all these values. I probably won't include all of them when I'm graphing. But we're going to restrict the domain, and I know that I'm going to start with the positive side. So at 0, we're talking about sine here. So again, we're talking about sine, we're talking about the y value. So my y value at 0, okay, so at 0 here is going to be 0 as well. And then at pi over 6, we have a value of, excuse me, at pi over 6, we have 1/2, then we have the square root of 2 over 2, and then so forth and so on. So if I continued to fill this out, at pi over 6, we had 1/2 for sine. So again, remember, sine is your y values on your unit circle. Pi over 4 is going to be the square root of 2 over 2. And then the pi over 2 is going to be 1 because that's 90 degrees. So this is 30 degrees, 45 degrees, and 90 degrees. Yes, we skipped 60, and that's okay. So then we have negative 360, negative 45 degrees, and negative 60 degrees. So remember, we used negative 30 degrees, the same thing as 330. So we're going to be using negative 1/2 here. Then we have negative square root of 2 over 2, and we have negative 1. Now, what we're going to do is what we did here is we restricted the domain. So we restricted the domain, and there's a purpose for that. So if you think back to when we were doing inverses, we had what we called 1-to-1. Now, 1-to-1 means that only one x and one y will apply to each other. It will pass the horizontal line test and the vertical line test. So it has to pass those two things. Now, if I have a sine graph will pass the horizontal line test. I could do a vertical line anywhere, but it wouldn't pass the horizontal line test. So in order to make it 1-to-1, we're going to restrict the domain. So when I label this, I'm just going to label this 0. I'm going to do 45 degrees, 90 degrees. This is negative 45 degrees, negative 90. And I'm going to do 0.5 and 1, negative 0.5 and negative 1. All right, so I'm going to graph these. Now, the only other thing that I need to know is what is the decimal value for negative square root of 2 over 2. So if I actually put that into my calculator, I would get negative 0.71 and positive 0.71. So if I graph this, and I actually graphed my values, so at 0, 0, I'm still going to have 0, 0. All right, and then at 30, So here's 30 right here. So actually, let's skip 30 and let's just go straight to 45. Okay, so at 45, we're going to do approximately 0.71. And then at 90, we're going to do 1. Okay, now I'm going to go back in the negative direction. So in the negative direction, at negative 45, I'm going to do negative 0.71 and negative 1. So this graph right here would be my sine graph. We restricted the domain. So just to make sure we're clear, if I continued this graph here, I would continue my graph. I would continue my graph and it would start to look like a sine curve here. So those pieces are what we're restricting. So we're not going to repeat our y values further than negative 90 and positive 90. Okay. So with that being said, sorry, I'm going to erase some of this. With that restricted domain, we now have a domain that is going to be between negative pi over 2 or negative 90 to pi over 2. And then our range goes from negative 1 to 1. Okay? Now, the question is does this graph have an inverse? And the inverse, is it a function? So the answer to this is yes. And the reason is because it passes the vertical line test and the horizontal line test. And we restricted that domain to make it fit. We did that in order to make it a function. So we restricted it. So the inverse. So if I flip those values around, so my domain should become my range and my range should become my domain. So this should be negative 1 over 1 and this should be the square root of 2, negative pi over 2 to pi over 2. Or negative 90 to positive 90. So again, I would label this. So let's do negative 0.5 here, negative 1, 0.5 here, and positive 1. And then we'll do 45 degrees, 90 degrees, negative 45 degrees, and negative 90 degrees. So we're going to take that table that we had earlier and we're going to flip-flop them. So like these are going to switch places. So my x is going to become my y is going to become my x. So we're going to do negative, so we'll start at 0, 0 again. I'm going to do positives first because it seems like positive normally is easier to see. So we're going to do 45. So we're going to do 0.71 and 45 degrees. So I'm going to go to 0.71 and 45 degrees. And then I'm going to go to 1 and 90. Now I'm going to go back and do the negative side. Whoops, sorry guys. And then I'm going to go to negative 0.71 and 45. And then negative 1 and 90. And you can see that that is the inverse of that function. Okay. Now, if we were to actually put these on a graph together, they would still be an inverse and they would still reflect over the line y equals x. It still has that reflection there. Now, in class, we had some confusion and we were talking about the fact that our unit circle is restricted. So we talked about the restriction there is going to be in quadrant 1 and in quadrant 4, excuse me. So we're going to 90 degrees and negative 90 degrees. Okay, so we're going to stick to quadrant 1 and quadrant 4 for the inverse. So I have arc sine and a sine inverse mean the same thing. They both mean inverse. They're just two different notations that have been used at different times of math, but they still mean the same thing. Now, when we talk about sine and the sine inverse, we stick to quadrants 1 and 4. The other thing that there's two properties, and these are the two properties that we were talking about in class that I need to clarify. So after going back and verifying myself, I can see that if I have the inverse, now remember, the inverse means that I'm giving you the side, you're going to tell me the angle. And if I tell you what the angle is, and then I give you the side, and then I ask you to find the sine of the side again, you're basically going back to the original answer. So that applies in this situation. If I ask you to find the inverse sine, and then I give you the sine inverse, then that means it's going to equal x. But that only applies if it's between negative 1 and positive 1. Why? Because the domain is restricted between -1 and +1. And vice versa, if I ask you to take the sine inverse of sine, then that means that my x will equal the it will still equal that x value, but that only applies if my values are my inverse values are between -pi/2 and pi/2, or -90 and +90. If it doesn't, then of course that rule does not apply. And why? Because the range is that of a sine inverse. So what we were doing is we were putting this into the calculator, and we were calculating these values. And we can put this in to Desmos, go sine inverse. Now, when you do these, this is very important, so make sure to make a note of it. So when you do these, you assume that your answer is in radians unless stated otherwise. So you assume radians unless stated otherwise. All right, now with that being said, I need to make sure that my Desmos calculator is in radians, and I'm going to put in -0.07. Sorry, 74. Now, I know this is going to work because I know that this 0.74 right here, okay, my domain value is between -1 and 1. So because it's between -1 and 1, I know that I'm going to get an answer which is going to be -0.83 radians. Okay, so that's radians the radians is what we're putting in. So 0.083, okay, is your actual angle measurement that they're looking at. Okay. Now, the next one. So when I look at this one, here's my value. So according to this rule up here, so up here, I have sine and sine inverse, and it should equal x. But here's the problem. My x value does not fall between -1 and 1. So it doesn't fall within my restricted domain that we applied, okay? So since it doesn't, it's undefined. And I can prove that by putting it into my Desmos calculator. So I have sine and sine inverse, and I could put in 5, and it's going to tell you it's restricted, or it's undefined, because it doesn't fall within the restriction. And then we come to C. So this is the one that I needed to clarify. So I have arc sine. So arc sine is the same thing as the inverse up here. So I have sine inverse of sine. So according to the property x, this should equal 2.36 pi. But here's where the issue lies. So in order for this to be true, it has to fall between -pi/2 and pi/2 according to the domain restriction. The range restriction. Why the range restriction? Because you're finding the sine value. So you're actually looking at the original domain, which is now the range of the inverse. So if that doesn't apply, if this value doesn't fall between there, which it doesn't, okay, then it's not going to equal x. It's going to equal another value. So I can plug that right into Desmos. So sine inverse of sine of 2.36 pi. And I get my 1.31. Now, why did that turn out that way? Well, I have 2.36 pi, okay? And if I actually subtract 2 pi from that, a whole rotation, that gives me the answer that I'm looking for. Because it's not going to give you the value outside of the restricted domain. But either way, you can still put it into Desmos. So that property still applies. It's not going to equal the same thing as long as it's outside the restriction. All right, so then we're going to do the next ones without a calculator. So we're really going to have to think about using our unit circle here. So in this particular problem, we're talking about sine. And since we're talking about sine, we're going to be looking at the inverse. So we're looking at where does my sine value equal -1/2. So I'm asking you, so this is my sine inverse, so -1/2, and here we are, sine is -1/2, it's the y value. But your answer cannot be 330, because remember, we restricted the domain, and the domain has to fall between negative 90, okay, and 90. So if we are looking at between negative 90 and 90, the range is what we're actually restricting. So our y value here has to fall between negative 90 and 90. So if that's the case, then my answer here is going to be the equivalent to 330, which is going to be negative 30 degrees. Or you could say it in radians, which is negative pi over 6. All right, so again, we're going to look at this particular example. So I have the sine of 7 pi over 4. So I'm going to come look at 7 pi over 4 right here. And I can see that that is 315. But I know that 7 pi over 4 produces this sine coordinate here, which is negative. So I still have the sine inverse, and I know that it equals negative square root of 2 over 2. All right, so if I have negative square root of 2 over 2, then I know that technically that angle measurement, that inverse measurement, is going to 315, but we can't put it as 315. We have to put it as negative 45. So we have to maintain our restrictions here. So that's going to be negative 45 degrees or negative pi over 4. So I will reference you back to this rule right here. So in this rule, we said that if I'm doing the inverse, it has to fall between negative pi over 2 to pi over 2, which is why this answer didn't come out to be that number right there, which is why it doesn't come out to be this one. So it comes out to be the value that is between negative 90 and 90. So 7 pi over 4 is the same thing right here as negative pi over 4. So that's the reason that that rule doesn't apply if it's not in the correct restriction. And the last one. So we're looking for negative square root of 3 over 2. So we have negative square root of 3 over 2, and that's going to be at positive 300. Well, we can't say positive 300. We have to apply that, and it's going to be negative 60 degrees or negative pi over 3. All right, so now we're going to venture to the next thing, and we're going to talk about cosine. So when we're talking about cosine, we're actually going to be looking at restricting it from 0 to pi. Now, why are we restricting it here? And I'm going to come back and I'm going to show you for cosine is we have cosine is our x value, so we do not repeat any x values in quadrant 1 and 2. We do repeat x values starting in 3 and 4. So when we restrict cosine, cosine is going to be restricted between 0 and pi. So again, I would fill this out and I would look at my value. So at 0, we have a cosine value of 1. Okay, so I'm just referring back. Then at pi over 6, I have the square root of 3 over 2, the square root of 2 over 2 for pi over 4. And then at pi over 2, I have 0. So again, I just copied those values that I identified for the x value for cosine. All right, so then I have for 2 pi over 3, that's going to give me negative 1/2. And then I have negative square root of 2 over 2 for 3 pi over 4. And then I have 5 pi over 6. I have negative square root of 3 over 2, and then negative 1. So when I'm looking at this, we're going to call this, we'll start here at 0 degrees. And we're going all the way to pi. So let's just set it, so let's do 45 degrees. No, let's do 90. Sorry, let's do 90 here, and let's do 180 here. Okay, so let's kind of chunk it up evenly. And again, we didn't go higher than 1, so we have positive 0.5 and 1, negative 0.5 and negative 1. So at 0, I have 1. Then at 90 degrees, it's going to be 0. And then at 180, it's going to be negative 1. So we have this graph for our cosine. So our domain is going to be 0 to pi, and our range is going to be -1 to 1. And again, we restricted this graph, so the answer is yes, my inverse, because we restricted it to be 1 to 1. And we restricted it ourselves. And we knew we wanted to restrict it because we didn't want any repeating values for cosine. All right, so if we flip our values around, this is going to become -1 over 1, and my range is going to be 0 to pi, which is exactly what happens here. So we have -0.5 and 1, 0.5 and 1, and then we'll do 45 degrees and 90 degrees. So at 1, okay, so we're going to do the exact same thing here. So we're going to flip them and do a 1 and 0. So 1 and 0 is here. And then we have 45 degrees is 0. So that's 0 and 45. And then at pi, we have -1. All right, so we have our inverse of cosine. All right, so then we kind of think about our properties. So again, with our properties, we are going to focus cosine on quadrants 1 and quadrant 2. So we're going to focus on Q1 and Q2. So that means that we're going to go between 0 and 180 degrees for cosine. So we can focus that on quadrant 1 and 2, which means that when we flip them around, our domain has to fall between -1 and 1, but our range has to be between 0 and pi. So again, those restrictions apply. We can equal x the same way we did earlier. So x can equal here, but that only applies if it's between -1 and 1. Again, if we do the inverse of the inverse cosine of cosine, that only applies if it's between 0 and pi. So we can put this in the calculator. Now, when I'm talking about my inverse, remember my inverse has to fall between 1 and -1. This right here does not fall between -1 and 1, so this is going to be undefined. And if you put this into the calculator, it will tell you that it's undefined. And again, you assume it's in radians, as before, just like we did previously. Now, this is between -1 and 1, okay? So remember, this is radians, this is radians. Now, it falls between that value, so we're looking at this option here. So we're looking at the inverse, cosine inverse of that. So if I'm talking about pi, so pi is 3.14. -1 does not fall in that range, okay? So it is not going to equal -1. So if I'm looking at it and I put it into the calculator, so I have the cosine inverse of cosine, and if I put in -1, it's going to apply it based off of the restrictions, and that answer is going to be +1. And I can look at that on the unit circle. So I'm talking about finding the cosine inverse of -1. So cosine is -1, okay? And it's going to apply right here. So if we're talking about -1 for 180 degrees, it has to restrict itself so that, cosine of -1 is at 180, and then 180 degrees of the inverse is going to give me pi or 0. So we're going to look at it in terms of 1. All right, and then the last is we are going to put in the inverse. Sorry, let me go back to the page. So the cosine inverse, we're just practicing putting this in the calculator. We have cosine of 1.36 pi. And we should get, for cosine there, we should get 1.13. And again, the reason that is because it's outside of pi, so 2.36 pi is outside of that normal range, and it's not going to work for us there. So it's going to give you the value between 0 and 180. All right, so now we're going to do the inverse of -1/2 of cosine. So when I come to cosine, I'm looking for 1/2. Well, that's going to occur at 120 degrees. So at 120 degrees, that's going to be the same thing as 2 pi over 3 for radians. All right, so the question here is, does this apply for 7 pi over 4? So 7 pi over 4 is going to be 315. So 315 is outside of my typical range. So since it's outside of quadrant 1 and 2, all right, so I'll say again, we have 7 pi over 4 does not fall between quadrant 1 and 2. So this cannot work for us. This is going to be undefined because it falls outside of our restriction. All right, and the last one. So we have negative square root of 2 over 2. That is going to fall in 135. And if I have 135 here, that's going to give me, 3 pi over 4 for the radians. All right, and the last one we're going to talk about is tangent. Now remember, tangent is the division of sine and cosine. So when I'm looking at these, I'm looking at the division of the two. So you would have already previously done this, but we're going to do this based off of our simple value. So I'm not going to fill this whole thing out, but we're going to restrict it from pi over 2, and let me kind of explain why. So we have y equals the tangent of x. So remember we have those vertical asymptotes. So we're really going to only be looking at that one section, and we're going to be looking at from negative pi over 2, and we're going to restrict that x value so that it's pi over 2. So we're only, pi over 2. So we're only going to be looking at that middle section before we hit those vertical asymptotes. We don't want that to happen. All right, so if we look at negative pi over 2, that's undefined, and this one is undefined. So what's happening in the middle? Well, if I'm at 0, so remember at 0, let's kind of clear our stuff off again. All right, so at 0, we're taking 1, dividing it by 0. All right, so then we're looking at 0. So if we're doing sine divided by cosine, it's going to be 0 divided by 1, which is just going to equal 0. So this right here is going to equal 0 for that one as well. And then we have the next easiest is if we divide the 45s. So if I divide the 45s, that's going to equal 1 here, and it's going to equal 1 here, except for this one's going to be negative. So I'm just going to go with the easiest ones to graph, and we're going to do it that way. So based off of that, we're going to do 0.5, negative 0.5, and negative 1. Then we have 0.5 and 1. And then we're just going to go between, so we have 90, so we have negative 90 and negative 45, and then 45 and 90 on this side. All right, so we had 0, 0 initially, and then we knew they were undefined at 90 and negative 90, okay? And then at 45, it was positive 1 and negative 1. Oops. So we have negative 1. So we have that, basically that vertical asymptote on each side because we restricted it, but we have those pieces that are restricted there. So we're going to continue to approach, okay, the undefined values. So when we do tangent, we are restricting the tangent, but we cannot include negative pi over 2 and pi over 2. We just go between them. And then my range is going up, so it's going to be negative infinity to infinity and down. So the question here is this a function? So in this particular situation, it will pass, based off our restrictions, the vertical and the horizontal line test. So the answer here is yes, and it's yes because we restricted it. So my domain is now going to be negative infinity to infinity, and my range is going to be negative pi over 2 to pi over 2, or again, negative 90 to 90. So if I regraph this, so I have negative 0.5 and negative 1, 0.5 and 1, And then we're going to do 90 and 45, and then negative 45 and negative 90. So again, these are our vertical asymptotes on this side. And we would flip those values. So where we had 0, 0 still going to be the same. But at 45, I'm going to equal at 1 and 45, and then negative 1 and negative 45. So we're going to have this graph here, and it's going to do that, whoops, it's going to do that curving on both sides, okay? Now, based off of that, my properties for tangent, again, we're only going to focus on quadrants 1 and 4. So we have Q1 and Q4. And we do have to make sure we have go between 90 and negative 90. So we're going to focus that these are negative 30, negative 45, and negative 60 instead of 315, 330, and so on. So we're going to focus on 1 and 4. And since we're going to focus on 1 and 4, we still have some properties that apply here. So this only happens if x equals x, only if my x is between negative infinity to infinity. So that'll always work for us, okay? Because we always are going to be able to apply all real numbers there. But if I have the tangent inverse of tangent, my x has to fall between negative pi over 2 and pi over 2, or negative 90 and 90. All right, so starting at the beginning, I'm going to put this in the calculator. So I have tan inverse for the square root of 3. And I have 1.05. All right, and then this one, I have the tangent of the tangent inverse or arctangent of negative 4. And that's going to equal negative 4. Well, why did that apply? Well, we had the tan inverse, and I have tangent. It should equal the inside because that rule applies for all real numbers. Now for this one, does that apply? Okay, so is 3 pi over 4, does that fall between negative pi over 2 and pi over 2? Well, the answer to that is no, so we're not going to get 3 pi over 4. So if I'm actually thinking about this in terms of the unit circle, so I have 3 pi over 4. All right, so remember before we were looking at quadrant 1 and 4, so 3 pi over 4 is over here. All right, so 3 pi over 4 is going to give me a negative 1. Well, then once I have a negative 1, all right, so 3 pi over 4 will produce negative 1 for tangent because I divide them. Well, negative 1 is actually going to apply to the same quadrant or the same value in quadrant 4, which is going to be negative 45 degrees, okay, which is 7 pi over 4 for that one. So if I plug this in, I'm going to do the tangent inverse of tangent of 3 pi over 4. Okay? So that's going to give me negative 0.785. All right, so now we're going to actually find it ourselves, and then we're going to do a mixture of practice. All right, so we have negative square root of 3. All right, so when we do tangent, first of all, we need to think about what can be negative in quadrants 1 and 4. All right, so when we did tangent, remember tangent is, let me erase some of this, tangent is sine divided by cosine. All right, and in quadrant 1, I have positive, positive, and then in quadrant 2, I have positive, negative. So it has, quadrant 4, it has to be in quadrant 4, and the square root of 3, which one is that going to apply to? All right, so if we do, if we divide those out, and I look at the square root of 3, all right, then I'm going to be looking at the square root, the sine divided by the cosine. So sine divided by the cosine here, how is that going to produce it? Well, remember we multiply by the reciprocal, okay? And that's going to go away, so that cancels. So I have negative 1 over the square root of 3. Well, that's not going to work out because we need just the square root of 3. So it's not going to work for negative 30, so let's do the other one. So I'm going to do sine divided by cosine, we're going to go ahead and multiply by the reciprocal, and that does equal negative square root of 3. So we're not going to use negative 30, though. We're going to be using negative 60 degrees. All right, so negative 60 degrees is the same thing as negative pi over 3. All right, so then we have the tangent of pi and then the inverse of that. So the tangent of pi, so we started with, so we go to pi. So tangent is sine divided by cosine, so that's equaling 0. So far, this right here equals 0. So they're asking us, what is the tangent inverse of 0? So when I look, so tangent inverse of 0, which way is it going to equal 0 here? Well, I mean, it's still going to equal the value that we're looking at. So when we look at the angle measure of 0, then we're looking at sine divided by cosine is still going to equal 0. So we're still going to equal 0 here. And then we have the tan inverse of negative 1. All right, so let me kind of erase some of this stuff that I've written over here. So we're still looking at a negative value, okay? So this, oops, and I meant to put a degree symbol, 0 degrees there. So we're looking at the tan inverse of negative 1. So negative 1, the only way that can happen is if I'm in quadrant 4, okay? So remember, quadrant 1 and 4 is where we're focusing. And I would have to divide by the same thing in order for it to happen, which is going to be 315. Well, we're not going to use 315. We're going to use negative 45. So negative 45 is the same thing as negative pi over 4. All right, so now let's mix it all up. So we're going to start with the sine inverse. So we're starting with sine. All right, so we're really going to have to remember where we're focusing our attentions at for each piece, okay? All right, so we want the sine inverse of 1/2. So remember, sine only occurs in 1 and 4. All right, so we're looking for the sine inverse of 1/2. So when we're looking at sine, we're looking at the y value. All right, so my y value, the only y value that has a positive 1/2 is going to be 360. So this right here is 360 degrees. So now we want to figure out what is the cosine of, I keep saying 360, of 30 degrees. So the cosine of 30 degrees, so we're going to go back. The cosine of 30 degrees, so we're at 30, is 3 pi, or the square root of 3 over 2. So this is going to be the square root of 3 over 2. Now, how can I verify that? It's obviously not going to give it to you in radical form, but if you get your value, you can always divide it out and see if it matches what it should, okay? All right, so for the next one, we're going to do the cosine of pi. So remember, cosine only works between 1 and 2. So we're looking at pi. So if I'm looking at pi, so the cosine of pi is going to be negative 1. Okay? So this is negative 1. All right, so we're doing the tan inverse at negative 1. All right, so tangent, remember we have to focus tangent on quadrant 1 and 2. And the only place that tangent can occur negative is in quadrant 4. Well, to get negative 1, I'd have to divide sine over cosine, which is going to be 315, or negative 45. So this equals negative 45 degrees, or negative pi over 4. All right. And again, I can check that. If I plug it into Desmos, I can check that the tan inverse and then the cosine of pi, that gives you negative 0.78. So negative pi over 4 gives you the same value. All right, so we're looking for the tangent of negative 1, or the inverse of tangent of negative 1. So again, we kind of already just found that. We just found that this right here, the tan inverse of negative 1, was 45 degrees. So we know that this is 45 degrees, or excuse me, negative 45 degrees. So now we're going to look at sine. Well, what is the sine value of that? Well, it has to be that negative square root of 2 over 2. So we're looking at the sine of negative 45 degrees, which is going to be negative square root of 2 over 2. All right. And then number 4. So the cosine of pi over 3. So if we go to pi over 3, cosine is 1/2. So we know this is 1/2. And now they want us to find the sine inverse of 1/2. Well, remember, sine is focusing on 1 and 4. So we're finding positive 1/2 for sine. So positive 1/2 for sine is your y value, which is going to be 30 degrees, or pi over 6. So this is equaling 30 degrees, or pi over 6. All right, in our last example, we have the cosine of 11 pi over 6. So remember, cosine is 1 and 2. So then we have 11 pi over 6. Well, 11 pi over 6 is all the way in quadrant 4. So when we're talking about the cosine of 11 pi over 6, hold on, let me make sure I'm saying this correctly. Okay, so we're doing just the regular cosine. So the regular cosine of 11 pi over 6 is going to be the square root of 3 over 2. Not because I was thinking about the inverse. So the square root of 3 over 2. Now we're going to find the cosine inverse of negative square root of 3 over 2. So we're going to go find in 1 and 2, we're going to go find the cosine of negative 3 over 2. And that negative square root of 3 over 2 is right here, which is going to be 150 degrees, or 5 pi over 6. All right, let me, actually, you know what? I was looking at the negative. That is my mistake. It is not negative. It is actually positive. Sorry about that. So that is wrong. So let's go back. So we're looking for the positive 3 pi over 2. The positive 3 pi over 2 is actually going to be located right here at 30 degrees. Okay, so that's going to be 30 degrees, or pi over 6. So I hope this kind of clarifies for you guys. But again, essentially, when you're doing these examples, you can put them into Desmos. The only problem is that they give it to you in radical form or in radians. You're going to have to compare those answers.